Hey everyone, and welcome back to Barcode. Today we're going to talk about labels, the continue and break keywords and how these three work together, and finally exception handling that's going to let you manage errors and prevent your program from crashing. So without wasting any more time, let's go. Let's start with the break keyword. When we talked about the switch statement, we already touched on it briefly, but now we're going to have a better look. Let's say we have an array of integers called numbers with a couple of numbers inside, and we have a target which is 5 this time. And what I want my program to do is to go through this numbers array and find me the target. And I can do this with a for loop. And what this does, it iterates through the numbers and checks them one by one. It prints out in each case are looking at this number, and in case the number equals the target, gonna print out target found. And when we run this, we're gonna see we are looking at 3, we are looking at 2, 10, 7 in order. When we reach 5, Java says we are looking at 5, target found, and then keeps on going. But when we find a target, we don't want to keep on going because we found it already. So in this case, we can include a break keyword, which gonna tell Java break out from this loop. So if Java finds a break keyword, it checks in which loop was inside of, and it ends that loop. So when we run this again, we're gonna start the same. We're gonna keep looking at the numbers 3, 2, 10, 7, 8, 5, and when we find 5, then the if statement becomes true. Java prints out target found. Then comes the break keyword, which tells Java break out of this for loop. Now let's have a look at it with a while loop. And for this, we're gonna create a guessing game. We're gonna have a secret number, and the user has to guess that number. So for this, we're gonna need an integer called secret number. It's gonna be 13. We're gonna need an integer to store the guess of the user. We're gonna need a scanner, so we can read in that guess. It's gonna be Leo again. Leo is a new scanner. We're gonna read in from the keyboard, so system.in. And we're gonna also ask the user if he or she wanna continue to play. So for this, we're gonna have play. Let's say if it's 1, he or she wants to continue playing, and if it's 0, then no. And while play equals 1, so as long the user wants to play, we're gonna ask please guess a number, and then the guess gonna be the number he or she guessed, so leo.nextInt. And if the guess was correct, if the guess was the secret number, so guess equals secret number, then we're gonna type out you are right, and then we're gonna break out of the loop. And in case we stay in the loop, we're gonna ask again, wanna keep on playing? And the play gonna be the answer. And in this case, we're gonna type in 1 or 0. So wanna keep on playing or wanna stop with the game. Let's try it out. Please guess a number. 30. Wanna keep on playing? Yes. Please guess the number. 2. Wanna keep on playing? I don't wanna keep on playing. The while loop ended because I said no, I don't wanna keep on playing. So the condition became false. But now let's keep on playing until we guess the number. Start with 30 again. I wanna keep on playing. 4. I wanna keep on playing. And 13. You are right. And what happened here? The guess was correct. It was the same as the secret number. Java printed out you are right, and then it broke out of the while loop. So it didn't check the condition anymore, although play stayed 1. But because there was a break, it told Java, okay, end this loop. And that was the end of the program also. I hope that made sense. So just to sum it up, the break keyword is used to break out from a for loop or a while loop, and it's also an important part of the switch statement. I'm gonna copy paste the code here from a previous video. And there is also another scenario when you can technically use a break keyword, but it's a really bad idea. I'm gonna mention it when we talk about labels, just to cover all bases, but it's something you really don't want to do. Now let's move on to the continue keyword. I have a similar example like before for the break keyword. I have a single number and an array of integers, and what I'm gonna do, divide 50 with each of these numbers from the array. And if I do this with a for loop, it's gonna look like this. I'm gonna print out with which number I'm dividing with and then what the result is. And if I run this, we can see dividing by 5, the result is 10, and so on until we reach dividing by 0, and then Java throws an exception because you cannot divide by 0. So in this case, I can use a continue keyword like this, which in the if statement, I'm going to check if the divisor I'm looking at right now, it's 0 or not. If it's 0, we're going to print out you cannot divide by 0. And then the continue keyword tells Java, continue with the loop, but skip this iteration. So when Java sees this, it's like a mini break. It doesn't break out from the whole loop, but it breaks out from the current iteration. So everything which is after the continue in the same loop won't be executed. Java jumps back to the beginning again and checks, do I still have something to do in the loop? If yes, it goes on with it again. So if we run this, we see we divide by everything. Dividing by 25, that was the last one before 0. And when we reach 0, then Java checks that the divisor we're checking right now, it's 0. It evaluates to true. So it prints out you cannot divide by 0. And the continue skips the rest of the iteration, the rest of the loop, jumps back again, and because we still have 10 to check, it jumps in again with the number 10, divides it by 10, prints it out, and the loop ends. I hope that makes sense. Another example with the while loop, we're gonna come back to our guessing game. This time the secret number is gonna be 3, and we're gonna ask the user to enter a number between 1 and 10, just to keep the game simpler. And after we read in the guess, then we're gonna check whether the guess was a valid input, like the number was really between 1 and 10, and if not, we don't want to go on with the game because it's no point. Then we're gonna jump back again and ask again for the number. And we do this by typing if the guess is smaller than 1 or the guess is larger than 10, so it's outside of the range we want, then we're gonna tell the user invalid input. And with continue, we tell Java, skip the iteration, don't execute the rest of the code in the while loop, jump back to the beginning. And if we run this now, it's gonna ask us for a number. If we put in an invalid number, the condition if the if statement is true, so Java prints out invalid input. The next command is continue, which means skip this part, but continue with the loop. So it jumps back again and asks again for the number. And if you put in a wrong number again, the same. If you put in a number between 1 and 10, it means the condition if in the if statement is false, it doesn't come in anymore, then goes on. Guess wasn't the secret number, so it prints out wanna keep on playing, and if I wanna keep on playing, then comes back to the beginning again, and so on. If I put in an invalid number, we jump in again here, continue tells Java, skip the rest, but continue with the loop, so we come back again to the beginning, and now I put in the right number, and the loop ends. I hope that was clear also. A quick recap. Continue ends the current iteration, break ends the whole loop. So when Java sees a break keyword, it breaks out of the loop, it stops it and continues with the program. And if it sees a continue keyword, it jumps back to the beginning of the loop. And if the condition of the loop tells Java there's still work to do with the loop, then it goes on with it. So the continue ends only the current iteration and jumps to the next one if there is still some. And the break ends the whole loop. Labels let you name your loops. Let me give you a quick example. We're gonna have 2 arrays of integers, and we want to check if there is a common element in them. For this, we're gonna have a Boolean variable called found, we start with false, and when we find a common element, we're going to turn this into true. And we're going to do this with a nested loop, nested for loop, that looks like this. What this does, we have an outside loop that picks the elements from array number 1, one by one, and we have an inside loop that picks the elements from array number 2, one by one, and compares them to each other. And we're also going to print out which elements we're comparing just for clarity. So how this is going to work? In the first step, the outer loop starts, picks the first element from array 1, then jumps inside, and the inner loop gonna go through the array number 2 and gonna pick the elements one by one, 16, 1, 4, 3, and 13. Always we're gonna print out which numbers we're looking at, and if the two numbers equal, then we're gonna turn found to true and print out we found a common element. Let's run this. And if you see, we started with 10, that's the first element of array number 1, and we compared it to each number from array number 2 in order 16, 1, 4, 3, and 13. Then the inside loop ended because we went through the array 2. Then the outer loop went to the next step, picked number 7, went inside, and the inner loop went through the array number 2 again. And it went until we arrived to 3 and 3. It printed out, we found a common element, but then it kept on going. And the point would be, when we find a common element, to stop the comparison because we already achieved what we wanted. So in this case, we could include a break here that breaks out from the inner loop. Then we have to include a break here also to break out from the outer loop as well. But this is not so clean. It might confuse you what the program might do. So in this case, we can just use a simple break in the inside and say break out from the outer loop. And for this, we have to name the outer loop outer. Labels, you can name whatever you want. After that, you put a colon, and it means the loop comes after gonna have this name. So here, when I say break from the outer loop or break outer, Java won't break out from this loop only. Java gonna check where is outer, what is called outer, which loop, jumps there and says, okay, this is the loop that's called outer, so we're gonna break out from this loop. And if we run this now, it runs only until we find the element, and then it breaks out. If I don't have this, and I just say break, then it's just gonna end the iteration when we're checking number 3, but then it's gonna go up and check from number 2 against the array number 2 again. And as you see, when we found 3 equals 3, 3 wasn't compared to 13 anymore because we broke out, but only from the inner loop. And then Java went on and picked number 2 for the outer loop, and then went on with the inner loop again. So we just, with a normal break, we just break out from the inner loop, but if we have a label from the outer loop called outer loop, whatever you want to call it is up to you, and you put the same label here, and you run this, then this break gonna break out from the outer loop itself. I hope that makes sense. When we talked about the break keyword, I said there's a special case when you can also use it. I'm gonna copy paste the code from the previous video when we talked about the scanner class. And what this mini program does, it just asks for your name, reads it in, asks for your age, reads it in, and then prints out what's your name and how old are you. Now, if I want, I can take a piece of code, surround it with curly braces, create a code block. I'm gonna do for this as well. And here, inside of this code block, now I can use a break keyword. Like, let's say someone says his name is Joe. Maybe I don't like that name. I don't want to deal with it. I can say if name equals Joe, then break out from this loop, from this code block. And if I have a code block, I can also name it. Let's call this name asking. And if I have nested code blocks, I can use a break keyword with the label to break out from a specific code block with a specific label. So it's technically possible, but it's really bad practice. This you can solve with other logic. Like you can put in a while loop where the condition is name doesn't equal Joe and keep on going until the name becomes something else than Joe. I just wanted to mention it so you know it's possible, but it's really not advisable to use it. And one last thing regarding labels. labels were made so you can use them together with the break and continue keywords, so Java knows from where to continue or from where to break out from. If you want to name a loop so you know what it does, please use a comment, not a label. Now on to exception handling. Let's run this code. For the name we're gonna give Joe, and for the age, Java expects us to give an integer because Leo is trying to read in an integer from the console. And if I type in something that cannot be stored in an integer variable, then Java gonna crash. But at least it tells us what was the exception. So how we can catch this, it's with a so-called try and catch block. Let's describe it first. You type try. In curly braces, you're gonna put in the code that you want Java to try, whether it's gonna throw an exception or not. So code that might cause trouble. And after that, if the code throws the exception, then you're gonna tell Java, okay, catch that exception that was thrown. You have to put in the name of the exception. And code the exception, let's call it E. And in curly braces again, code to be executed. So you put in the code here, what you want to be executed in case the code that you tried threw an exception. Let's comment this out. So here, the code that might throw an exception was this one. We type in try, curly braces, the code, and the exception we want to catch is this one. Just copy it in here. We call it exception or E. You can give whatever name you want. And in curly braces, we're going to type invalid input. Now I also have to give an initial value here, say -1. And if we run this, name is Joe, age is 32. That was a valid input. So Java just checked this code, ran it. No exception were thrown. So it just ran it normally and went on with the code and printed out what the name was and how old the person was. But if I give in something wrong when it asks for an age, so my name is Joe again, but my age is ABC, then Java tries this part. I put in something wrong. The exception was thrown like before, but it was caught by the catch part. And then this part was executed. And after that, it just printed out your name is Joe and the age stayed the initial value. Now let's try another exception. Before, when we talked about the scanner class, we had a string called in between. And we read everything in there. So the age was first read in the in between equals leo.nextLine. And then we passed that value into the age variable. So age equals integer.parseInt and in between. And what this did, when the user gives in an age, it's read in as a string, so you can't really put anything that causes an exception or causes trouble. And after that, we convert it into an integer. And if we run this, and the name is Joe, and the age is ABC, we're gonna get a different kind of exception that's called number format exception. And we deal with this the same way like before. Let's just give the initial value again. This part is that might cause trouble. So this we're gonna surround with a try and the catch block. Try this code. Java tries it. If the exception is thrown, then we tell Java, okay, catch the exception. Just copy it out from here. It's a number format exception, so I'm gonna call it NFA. And if that is caught, let's type out, it is not a number. And if we run this, it works like before. Name is Joe. If I do something wrong here, Java tries the code. It prints out your age, please. The in-between gets the value, gets the ABC. Then Java tries to pass it, so convert it to an integer. It cannot. The exception is thrown, but it's going to be caught by the catch part. This is the exception that was thrown. And then this is the code that's going to be printed out. It is not a number. and then Java moves on and executes the rest of the code. And if we give in good values, then it tries the code, nothing wrong happened, so it executes it normally and then moves on. So you saw in the two cases the exception was called differently. So when you try to catch an exception, you have to tell Java which exception you're trying to catch. Because here, if I go back to the first example and I try to read in the input directly into the age variable, age equals leo.nextInt, then the exception that's being thrown is not a number format exception, but an input mismatch exception. So if I call myself Joe and age is ABC, I was trying to catch the number format exception, which happens when I try to convert a string into an integer that cannot be converted into an integer. But here what happened, I was trying to read in a string that is not an integer, if that makes sense. So the exception was a different one. In the catch block or the catch part, you always have to tell Java which exception you're trying to catch. If you're not sure, you can also use the superclass called exception. This contains all possible exceptions in Java. So technically this is gonna work. If I put in Joe and ABC, it still catches it. But it's also bad practice. It's good to know which kind of exceptions you can encounter and use that specific exception. If you want, you can also import the classes, the exception classes, into your program by typing import java.lang. The name of the exception. And what this does, it lets you refer to that exception only by its name. So it looks a bit prettier in your code. And it does all the same. So if you know which exceptions you might encounter or which exceptions you want to deal with in your program, you can just import those. And then you can type in the catch statement only the name of the exception. And here you also have a finally block. What this does, whatever code you put in here, it's going to be run no matter what happened in the try and the catch blocks. So let's put a print statement. This will be definitely run. And what this does, if something bad happens here, before your program crashes, Java gonna run this. So for instance, if we don't convert the age to an integer, but we try to read in directly, so Leo should get the next integer. Here we were trying to deal with the number format exception, which is the exception when you try to convert a string into an integer that cannot be converted. But here, now we're gonna try to read in directly to the integer, which is an input mismatch exception. So it's not the one we are trying to dealing with. So if the name is Joe and the age is ABC, then the exception what Java threw was the input mismatch exception. We didn't deal with that one, so the program crashed. But before the program crashed, Java still ran this part. So that's why it's this important. And it's used mainly to do some cleanup tasks or reverting changes what you might have done in the try and the catch statements. So whenever you finish writing a program, go try and crash it. Then you can see what kind of exceptions can happen. And after that, you can just use try and catch blocks in the code to deal with them. And here you have it. Now you know how can you use the continue and break keywords with labels and also how to deal with exceptions. I hope this wasn't all that complicated. And if something wasn't clear or you think I should have explained it differently, please let me know in the comments. And as always, if you like the video, please hit like and subscribe. It really helps a lot. Thank you and see you in the next one.